Hello everyone. So the topic of today's discussion is pulse response of RC and RL circuits. This video is a continuation of my previous video on current pulse response of RC and RL circuits. Although these two will be mostly independent, but in that I discussed about current pulse. In this video we'll be discussing about voltage pulse, and the basic concept will remain the same. So what will happen is, let's say we have a RC circuit and then we have a pulse input and we wish to calculate the value of output in steady state. So in order to find out the value of output for steady state, one thing that should be kept in mind for RC circuits is that the voltage across the capacitor in steady state will not change. It will ripple around its average value. The voltage across the capacitor will ripple around its average value at steady state, because capacitor will hold that value when there is no current flowing through the capacitor. So dU by dt will be 0 and the average value will be held. So VO will ripple around its average value. And what will be the average value of VO? So the average value of VO, for the average value of VO, it will be in steady state. So C will be an open circuit. The average value of the input is 2.5 because it is 50% duty cycle from 0 to 5. So since these two resistors are equal, the average value here will be the average value of this divided by 2, since there will be a voltage division since C is open. So it will be 5 by 2. 2.5 will be the average value at the input. So the average value here will be 2.5 times the voltage division, so it will be 1.25. So VO will ripple around 1.25 volts in steady state. Since the capacitor will hold its voltage in steady state, since there is no current, so dU by dt is 0 and V will be held constant. So it will just ripple around as the input varies. Obviously we are talking about the case where t is much less than tau, as the other case is very trivial to analyze. So now for the output current to the capacitor, since we know the output voltage varies from it is constant at 1.25. It will ripple around 1.25. So in order to find out the I0 value, this current will ripple around 1.25 over R. So if you wish to plot this current will look something like this. It will just ripple around 1.25 by R, since the voltage is rippling around 1.25. Now this current is oscillating between 5 minus 1.25 R, which is 3.75 by R, and 0 minus 1.25 by R, which is minus 1.25 by R. So this current, if I term it as I1, and this current if I term it as I2, let me use some colors for clarity. So if I plot I1 versus time and I2 versus time, I1 will look something like this, 3.75 by R and minus 1.25 by R, since VO is held at 1.25 and this is toggling between 0 and 5. So this will toggle between these two values. Similarly, I2, it will be rippling around 1.25 by R, since VO is rippling around 1.25 by R. And I0 will be just the difference of I1 and I2. So I0 will be I1 minus I2. When you subtract these two waveforms, it will shift down by 1.25 by R. So it will just shift down by 1.25 by R. This will become 2.5 by R. This will become minus 2.5 by R, because we will shift this down by this value, since I0 is a subtraction of I1 and I2. So this is how we'll get the waveform of I0. Similarly, we can analyze RL circuits also. So one note is that in steady state, voltage across capacitor ripples around its average value in the absence of impulses, obviously, and current through an inductor ripples around its average value. The reason is simple, because in steady state there is no voltage across the inductor. Inductor is a short, hence di by dt will be 0, hence current will be constant. So current will ripple around its average value. So now what will be the average value of the current through the inductor? So inductor will be a short in steady state. So the average value across the inductor at steady state, around which I0 will ripple, will short this out. Average value here is 2.5. This is short. So the current will be 2.5 divided by the series resistance 2R. So it will be 1.25 by R. Since inductor is a short, it will be average value at the input divided by the total resistance. So it will come out to be 1.25 by R. So I naught will repel around 1.25 by R. Now we wish to calculate VO. So for VO, what we can do is, we know that same I naught will flow here. So the voltage difference across the resistor will be rippling around 1.25 volts, since it will be this waveform multiplied by R. So it will ripple around 1.25 volt if we plot the voltage difference across the resistor. Now VO will be potential of this node minus the voltage drop across the resistor. And potential at this node is toggling between 0 and 5. This is rippling around 1.25. So output will be certainly this waveform shifted down by 1.25 volts. Since it will be the voltage across the resistor will ripple around 1.25 and we'll subtract it to get the voltage here. So 0 to 5, pull it down by 1.25, we'll get something like this as the output voltage. Now one thing to note here is the value of I naught in steady state DC wise will be 0, since there will be no average current that flows through the capacitor. So the average of the current through the capacitor is 0, which can be used as a verification check. And similarly here the voltage across the inductor will have 0 average value, which can be verified by the fact that VO is toggling between 3.75 and minus 1.25. This value is fixed at 1.25 volts, since the current is fixed at 1.25 by R. So when you pull VO down by 1.25 volts, you'll get something like 2.5 to minus 2.5. So voltage across inductor, if you plot, it will toggle between 2.5 and minus 2.5. And the average value will be 0 as expected, since inductor will be a short. So here the average value of the current is 0. Here the average value of the voltage is 0, and here the average value of the current is 0. Okay, so this is the main point that you should keep in mind. So voltage across the capacitor, which is VO, will ripple around its average value in steady state. Similarly, inductor current will ripple around its average value in steady state. Also, as verification checks, you can calculate that the current through the capacitor will have an average of 0 in steady state DC wise, and similarly voltage across the inductor will have an average of 0 in DC steady state wise. So this point will help you get these waveforms, and you can verify the voltage across the inductor as well as the current through the capacitor to have 0 values as the verification check for your calculations. Thank you for watching.